Hello everybody, welcome back to Electrochem, and today we will be predicting the products of an electrolysis reaction. Alright, to predict the products of aqueous iron nitrate, we first have to look at the reduction and oxidation rules for the electrolysis of an aqueous solution. With reduction, it's going to apply to the first component of the compound, which in this case is iron, and oxidation is going to apply to the second part, which in this case is nitrate. We're going to show you how to use and apply these very important rules in order to predict the products of an aqueous solution. Alright, so to help you with this, we're going to color code. We're going to write iron in green to match the earlier rule, which was in green, and we're going to write nitrate in blue, which is also used to match the earlier rule in blue. Because iron is a transition metal, you're going to write down the half reaction for which it corresponds to on your reduction potential chart, or one that matches with the element as well. So that includes charges as well. And for oxidation, because nitrate is not a chlorine, bromide, or iodine atom or ion, you are not going to write down the half reaction, and instead you're going to write the other equation, which in this case it is 2H2O going to O2 plus 4H plus 4E minus. And that is all you need to do in order to predict the products of an aqueous aqueous solution. You just need to learn and possibly remember the reduction and oxidation rules for an aqueous solution. Alright, to practice the next or the other side for oxidation, we're going to predict the products of the electrolysis of aqueous sodium chloride this time. And once again, we're going to be using the same rules, and we're going to solve it the same way. And to help you with this, we're going to color code once again, with sodium written in green to match with reduction, and chlorine written in blue to match oxidation. Because sodium is not a transition metal, we're not going to write down the half reaction, and instead you're going to write the other equation that was listed back in the rules. So in this case, that is 2E minus going to plus 2H2O going to H2 plus 2OH minus. Because chlorine in the rules matches up with oxidation, all you have to do is write down the half reaction that corresponds to your reduction potential chart, and that so it matches along with the element. And once again, that is all you need to do in order to predict the products of an aqueous solution, but this time doing so with oxidation. Alright, in the next example, you have to find the products of the electrolysis of molten sodium chloride. This case it is different because it is not an aqueous solution. Instead, it is a liquid ionic compound, thus molten NaCl. And in this case, we've also written the rules up at the top. This only applies to molten compounds, or otherwise known as liquid ionic compounds. And in this case, all you have to follow the rules is that the metal is reduced, and then the non-metal is oxidized. So in this case, the metal sodium is reduced. You write down the half reaction equation, and chlorine, the non-metal, is oxidized. And then you write down the half reaction equation for that as well. And then after doing so, all you need to do is balance out the number of electrons by multiplying, and then you combine both of the half reactions into the total equation. And that is the solution and how you find the products of the electrolysis of a molten solution. So thank you once again for watching, and see you around next time.